you all here for the new year. I am Stephanie McCowett. I'm the marketing manager here at Datamark. I'm excited to introduce you guys to John Green, who is one of our business development representatives at Datamark. He will be leading the charge here to discuss our processes and procedures for how Alabama achieved next generation 911 readiness. So without further ado, I mean, it seems like everybody knows what to do. We've been through this before. I'll give it over to you, John.
All right, thanks, Steph. Well, first, let me just thank everyone for taking the time out of your day to join us today. Some of you folks know me already. Again, my name is John Green. I'm one of the BDs here at Datamark. Just a little quick snippet about myself. I've been doing public safety GIS now for almost 24 years. I live in Eastern Tennessee. You might recognize the accent. I have 3 kids, all of them boys, and been married to my lovely wife now for going on 23 years this May. So enough about me. We want to kind of tell you the story of how Alabama's their journey towards next generation 911 and how they've prepared for this next phase of 911 call processing and the steps that they took to get there. So before that we do that, though, let's talk a little bit about the history of 911, because I think this is very relevant. So 911 actually started in Alabama. The very first 911 call was placed in Haleyville, Alabama in 1968, February 16th, 1968. And so let me get over to my slides. There we go. That was Speaker of the House, Rankin Fight, that placed that first 911 call. And it was picked up by a congressman at the local police department there in Haleyville. And so it was a huge step forward, because before that time, to receive emergency services, you had to dial a 10-digit number, and ultimately more than one 10-digit number. So you likely had a number for the police department, you had a number for the fire department, and you had a number for the local hospital or the local EMS department. And so this gave you one single number to call should you need emergency services. Now, it was basic 911, so that meant no location whatsoever. There was a chance that you weren't going to be routed to the right police station or the right EMS or the right fire hall. And so it was still a huge step forward, but it still needed some improvement. Long about 1973, the nation decided to implement this, to adopt 911 as the number to call for emergency services. And along about the late 80s, we saw about 50% of the households that were now being served by 911. And again, we're still in that phase of transitioning from basic 911 to enhanced 911. So in the late 80s, and especially the early 90s, we started seeing some enhancements to this 911 system. And those two main enhancements were being able to identify the location of the 911 caller and being able to use that location to selectively route 911 calls to the correct PSAP. Because I mean, if you're calling from Huntsville, you don't necessarily want your 911 call routed to Birmingham. They're not going to be able to dispatch for you. They're not going to be able to provide the right emergency response dispatch. So knowing the location of the landlines, we were then able to implement what we call selective routing and selectively route those calls to the nearest PSAP, the folks that could provide help the quickest and give you the best response times. So I know I remember having a rural routing box as a kid growing up, and that's the other thing that changed with a lot of these enhancement projects. To be able to be enhanced, now you had to have a house number and a street name so you could properly identify where that landline call was coming from. And then along about the same time, we started seeing a lot of cell phones come into play, or at least the beginnings of the cell phone era, if you will. And so we had to basically retrofit this enhanced 911 system to be able to accept wireless calls now. And that started out with phase 0 wireless. So just like with basic 911, with phase 0 wireless, you're simply getting the voice on the other end of the line. They don't know where you're at. They don't know where you're calling from. And that's, you know, even today, some of the very first question that a dispatcher will ask you is 911, where is your emergency? They want to know where you're at. And so 1996, the FCC said, okay, we're going to require a location for these wireless calls. And along about 1998, we started seeing the very first wireless phase 1 type of calls. And with wireless phase 1, you are getting some location. You know the tower's location, and you know the coverage area for the antennas on that tower. And then you also know which antenna the cell phone is communicating with. And so if you break down that coverage area by antenna, then you can get a cell sector worth of area. And just imagine that your coverage area around your antenna is a big circle, and it's divided into, say, 3 pieces of the pie. You know which pie that the piece of the pie that the 911 call is coming from, but you don't know the exact location with phase 1 wireless. Still a huge step forward, because now we can start using those cell sectors and the tower locations to selectively route wireless calls as well. So now we're able to ensure that wireless call, well, I won't say ensure, we can improve the ability to route that wireless call to the correct PSAT. And then the mid to late 1990s is really where we started seeing wireless phase 2 start creeping into the mix here. And so with wireless phase 2, we're narrowing down that location of the wireless caller, and we're doing that either one of 2 ways. We're either using trilateration off of the 3 or more towers, and some folks call it triangulation. I call it trilateration because you're using the sides of the triangle and not the angles. And so if your cell phone could see 3 or more towers, you could determine that location based off that trilateration. And then as cell phone technology advanced, we started seeing GPS chips predominantly throughout the entire cell phone industry. And, you know, we were able to start using those to determine the location of the wireless caller. Still not a perfect technology. You know, the GPS location is not an exact science unless you are using some pretty sophisticated equipment. And then if you're like I am today, you know, underground, and you dial 911 from a wireless phone, chances are you're not going to be able to see the satellites. So in the early 2010s is when we start seeing next generation 911 really become more of a thing. So everything up to that point has been analog technology. Your 911 calls were delivered over analog lines on a pair of stranded copper wires. And when we started looking at next generation 911, what we're doing is we're taking that 911 call processing into the digital realm. And my own state of Tennessee started 2011, 2012, I believe, to start creating the network and, you know, actually set up a next generation 911 network. So that's really when we started seeing a lot of the next gen networks come into play. So that's a little bit of history. Let's see, let me share this with you as well. And I won't go through each portion of this, but and I'll drop this in the chat before the session's over too. But this is our Alabama story map. And we won't go through every bit of this because a lot of this is repeat of what I just told you, and you know, we don't want to belabor. But there's the timeline that we talked about with a little more detail. There's Haleyville, Alabama, location of the first 911 call. Here's some more information on selective routing and how that's accomplished. It goes into more detail than what I explained earlier.
Hey, John, sorry to interrupt. We're getting some comments in the chat. We can't see your screen if you're sharing.
Yeah, I am sharing. What can you see, Steph?
We can see you.
Can see me, okay. Let me stop sharing and reshare. Is that better?
All right, there you got it. Yeah.
Okay. Sorry, guys, my apologies. Okay, so let me back up to the storyboard because you didn't see any of that. And again, I'll share this out in the chat there, and you guys can go into it a little more detail. But this again gives you kind of the history of 911, the location of that cell phone call, some more information on selected call routing, and then this kind of gives you an idea of the call path for phase 1 wireless calls, and then phase 2 wireless calls. And then this is some good information on the, or at least a good chart on the next gen 911 environment. Most of you folks have probably seen the components of this before, but this just kind of consolidates everything that goes into the next gen 911 environment for call taking. Okay, so let's talk about the Alabama Next Generation Emergency Network. And now we refer to it as NG 1.0. And I forget the exact date, but I'm wanting to say around 2010 to 2012. The state of Alabama started implementing a next generation 911 network, and they sort of tackled the problem in reverse order from what a lot of folks do, and I think it was to their benefit. They started with the wireless portion of the next generation 911 call. So they started bringing and aggregating all wireless telecommunications from all carriers into 2 different data centers there in Alabama. So at that time, if you were in Alabama and you placed a wireless 911 call, you were actually going through some digital technology and going through a next generation 911 system. Now that left the landlines kind of out of focus at that point. So if you dial forward to 2017, that's whenever Alabama really started focusing in on completing that NGen network, and they refer to it as NGen 2.0. And so this started bringing that landline portion of the equation into next generation 911. So one of our business partners in digital was selected to provide the core services and do the final connectivity, that last mile connectivity down to the PSAPs. And then they also started implementing some new equipment and technology there at the PSAP. So if you take a look at this map, 2019, we had only just a few of the ECDs, emergency communications districts, connected to that network. And just in a short amount of time, and this is a lot due to the efforts of not only the state 911 board, but the locals as well really pitched in and helped push this along. And then also, in digital's efforts to be able to pull this off in just 2 short years, we start seeing the entire state come online with core services and connectivity.
Hey, John, sorry to interrupt again. We have some questions in the chat about making the screen any larger. Is that a possibility at all?
I have it at full zoom, but can do that. Is that any?
Yeah, that looks great.
Okay. Okay, so that brings us to the fall of 2020. And that's when the state of Alabama State 911 Board started to look at the GIS component for Next Generation 911. And Datamark was selected to be the GIS software and services provider for that project. And so that's a little bit of the history of, from the very beginning of 911 down to where we're starting to tackle that last portion of the Next Generation 911 implementation. PowerPoint never wants to work when you want it to. All right, so let's talk about some of the challenges that we faced whenever we kicked this project off in October. The sheer scale of the project, there's 85 emergency communications districts that span over 67 counties. And so an emergency communications district can either be a municipality or a countywide emergency communications district. And so there's multiple municipalities within certain counties, and that's why there's more ECDs than there are counties. But you can imagine it's like having 85 citywide and countywide projects thrown at you all at once. So the sheer scale was a challenge. Now we were able to meet that challenge simply because of, well, a couple of reasons that we'll get into a little bit later. But one of the things is we have a very large staff to be able to do that. We were able to pull resources from our Michael Baker team, and we've got over 200 GIS folks on staff there in Michael Baker. So we were able to very easily move resources around and get that thing running. Local bandwidth was a challenge. You have some ECDs that they have a full GIS staff. They may have 2, 3, sometimes 4 GIS people that can help out with a project like this. And then you have other ECDs that the 911 coordinator is the addressing coordinator, is also the EMA director, and they sit in the chair with the headset on and answer calls 3 nights a week. And so sometimes local bandwidth was a challenge, and their focus isn't necessarily on doing GIS data work. It's more about answering 911 calls, and rightfully so. Another challenge was the variety of GIS technology that we had throughout the state. So you had some folks that were operating on inside of ArcMap using a file geodatabase. You have other ECDs that were on an enterprise geodatabase using ArcPro. And then you had some that were using shapefiles. You had some that used a custom off-the-shelf solution from their CAD vendor to maintain their GIS data with. And you even had some non-ESRI technologies like MapInfo and Intergraph. And so each one of those variations presents a different challenge in workflow, being able to get data from one point to the other and pull it into VEP and pull it into the state repository. Another challenge, no one had really ran validations on the data up until this point. And so, you've got folks that have been working on their GIS data for years, and all of a sudden now we're telling them, hey, you have to go in and fix some stuff. There's things that need to be changed, there's things that need to be updated. So, that first round of validations was eye-opening for some folks. And then, you also had a multitude of different CAD and CPE vendors throughout the state, and most of those being map-centric solutions, meaning that they simply don't work without GIS data. And for those who know about CAD and CPE systems, a lot of times you can change one field name in your data, and it can completely break your CAD, break your CPE. And so, another challenge was just don't break anything. Don't break my CAD, please. So next, let's talk a little bit about some of the tools and some of the services that we used on the project. So VEP stands for Validate, Edit, and Provision. And that's a cloud-based solution. And each one of the ECDs got their own instance of VEP. And they're able to upload data, run validations. Later on, we implemented an editor where they can actually go in and make edits to the data. There's also an aggregator solution that we'll go into more detail about here in a few slides. You still have to maintain an MSAG while you're doing this transition. Eventually the MSAG will translate into GIS data, but for the time being, you have to maintain that MSAG so you can continue to run location validations with it and use that for your legacy call route. We did a statewide ACE, or address comparison and evaluation, and to me that is a huge feat. So with ACE, what we're looking at is things that your typical synchronization between GIS data, your telephone alley database, and your MSAG, that synchronization process won't find. That's what we're looking for with ACE, the things that don't fall out with that synchronization process. If you're comparing your alley database over to your address points, that's well, great and wonderful, but with the amount of cell phones that are coming in nowadays and people dropping their landlines, you may still be missing quite a bit of information there. So that ACE process helps find that information. And then it also looks at things that just really slip by, like things like subaddress information, your apartments, your lot numbers, your suite numbers. And so we did a statewide ACE and found a whole bunch of missing addresses. VEP by its nature has an extract, transform, and load implement to it, which is really a game changer when we talk about not breaking a CAD system. Instead of having to change your schema drastically, we simply field map that over into the NINA data model, and that kept from having to make major forklift changes to the local schemas. Now, there were some schema adjustments. There's certain things, and we'll see that here in the next slide. There were certain schema adjustments that we did have to do. We performed a bunch of data remediation for ECDs, and then we did some GIS data consulting and strategic planning in certain areas as well. Okay, so data collection begins in October 2020. And we went around to each one of the ECDs and gave them a list of data that we were looking for the initial Gap 1 analysis. And so what we're looking for there in the Gap 1 analysis is things that would prevent you or slow you down from being able to onboard the data into VEP and be able to start running validations. And so I'll give you an example of that. Let me bring this over to where you can see it. And so our friends there at the State 911 board, Anderson Brooms, he nicknamed this document the stoplight document, and you'll probably see why. So you got certain things that are green, certain things that are yellow, and certain things that are red. And so what we're looking for here again is there anything that would prevent me from being able to run validations on my data? So anything in green passes. Anything that you see in yellow, technically we could get around, we could go ahead and onboard the data and we could technically run validations on it. But it's much easier to fix these yellow things ahead of the onboarding than it is after it's already been onboarded. And if you don't fix them, it's probably going to throw some of your validations off, give you some erroneous results. And then of course, anything in red is something that it's a complete stopgap. It's something that just has to be fixed before we can move forward. So just a good example of that, address number must be an integer. That's per the NINA data model. And what's probably happened here is this ECD probably has a text field, and they probably got some alphanumerics in their address number field. And so, we're going to be doing some pretty serious math on that field to be able to, determine the location of the address, be able to route calls and stuff like that. You don't want that alphanumeric in there because you're not going to be able to do the math on it. And so we're saying, hey, we need to change this. We gave the ECDs what the requirement for resubmission is, told them how to change it. And then, of course, if they wanted us to go in and make those changes, we certainly could. And again, with the theme of not breaking anything, instead of just changing that field, we created new fields and copied the data over into it to make sure that we weren't corrupting any of the data. All right, let's go back over to the PowerPoint. I do see one question there in the Q&A.
We do have a couple of questions. So this question is, do you have a PSAP boundary standard method?
Oh, that's a great question. So it varied with this project. It really depended on whether or not the ECD represented an entire PSAP. There's one area in Alabama that's inside of Jefferson County that has 14 ECDs. Jefferson County is composed of 14 ECDs, and so depending on what area you're talking about there, most of the time that with Jefferson County specifically, it was the municipal boundaries, because they were the call routing would be confined to that municipal boundary. In a lot of cases, it was the county boundary. And then in some other areas, there are certain instances where the PSAP coverages will lap ECD boundaries and even provisioning boundaries. So a standard, it's kind of hard to do a standard, but whenever you start piecing all that data together, you really need to look at those boundaries to make sure you're not overlapping or leaving anything out with gaps. I hope that answered the question. If not, drop me another line there.
All right. And then our second question was, we would like to know about how you secured capital funds for NG9-1-1 implementation. Do you know of any legislation or act for this project?
Oh, that would be a great question for the state of Alabama's 911 board, because we did not secure those funds. The state took care of that. We've noticed it in other states too, though. I know the state of Florida did something very similar to kick off several regional projects. And I can get you some more information on that, but I'm not sure the exact process now. I can put you in contact with someone who does know, though.
All right, awesome. So we'll follow up on that after the webinar today. We have your contact info, so thank you. And then one final question from same question who requested our initial question, which is, how do you specify and identify what other layer was used for the PSAP boundary?
Oh, another great question. So again, we started with basically the ECD layer and used that as the initial PSAP boundary. And then when we met with each individual ECD, we reviewed that boundary with them. And then you'll see in a couple of slides here, we start doing what we call cross-jurisdictional validations. And so as you start bringing all that data into an aggregated data set, if you have a basis of where your PSAP boundary falls and your neighbor's PSAP boundary falls, you start running those cross-jurisdictional validations, then you can refine that boundary a little bit better and make a better PSAP boundary. Great questions, guys. All right, so this is really where the rubber meets the road, so to speak. We've got the data onboarded into VEP, and we ran the first set of validations against the data. And that produced what we call the GAP2 analysis document. And I'll share that with you as well. So the first difference that you'll notice between these two is this is the GAP1, and it's 7 pages long. And then if you look at the GAP2, it's 44 pages long. So there's a lot more information in the GAP2, and that's because we're running all those validations. We run over 130 some odd validations on the data. They're grouped into particular groupings, so you don't necessarily see all of the validations in these lists here, but it goes into the corners and finds all the dust, if you will. So we won't go through this document in great detail, but I'll hit some of the highlights for you. So this first section here just identifies the layers that we looked at and the database files that we looked at and the number of records. So we have all 7 of the required layers and then the MSAG and the alley. And then we start getting into each individual layer and how those stack up against the next gen standards. And so, I think this is a pretty telling example here. So you've got misordered along road center line. Well, that's only 6% of the features that we looked at. That's still almost 10,000 records. And so it's important to look at each one of those and make sure that it's not something that can be easily fixed. And so you'll see that for each one of the layers. We run different validations on each one of the layers, of course, but we go into road center lines, we look at the MSAG, the number of alley records. It looks like they had some work to do here on the MSAG and the alley, and that could be for a number of reasons. And then we look at boundary anomalies. And then some of the ECDs chose to do the remediation themselves, and what we found over the years is there is a specific order of data remediation that you should really follow. And reason being is you could very easily, if you're not following that order, you can fix one anomaly and create 10 more. And you want to go in the reverse order of that. You want to fix one anomaly and remediate, fix 10 other anomalies. So we've come up with a pretty methodical process that we've just learned by trial and error over the years of, this is the order that you should go in. So we kind of painted that out for each one of the ECDs. And then the next section here is a summary of all the critical data issues. So these are the major gaps, the red lights, if you will. So here's things that you need to fix. It tells what field name it is, the requirement per NENA standards, the identified gap, and then how to fix it. And then the very last section here, this goes through each one of the anomalies that we found. And so anything that you see in red also appeared in this section up here. It's just we didn't want the ECDs to have to go through this entire list to fix just critical errors. And so we separated those out into its own little section so they could follow those critical errors and work on those first, work on the most important things first. And so you'll see the same theme there, the red, yellow, and greens. And then the other thing that we provided to the ECDs too, so we didn't want to just give you a list of your errors and tell you how to fix them, but we also wanted to give you some actionable data. And so if you look at these tables, you'll notice some commonality here. So each one of those validations that we run produces a layer that you can actually overlay in your map data. You can pull this out into Art Pro like I've done here and overlay that on top of your map data and then use that to go in and start remediating data and fixing data. So you'll see the validation in the table, and you'll also see the description of the validation.
All right, John, we got a couple more questions pop up in the QA. So the first one is, did the state require any consolidations of the ECDs?
Not at this time. Not at this time. Not as part of the project. I think there was, there may have been some earlier on before the GIS kicked off, but during the GIS phase, there wasn't any consolidations.
All right, and then our second one, what kind of UIDs did they use? Can you explain a little bit about that?
Sure. So there was actually a couple different ones. The one that we required for onboarding is actually not part of the NINA data model. It's specific to our solution. And it's for things like tracking anomalies, and there's some related tables that go into VEP. And so it's a pretty simple one. It needs to be a unique integer that's non-repeating. And so VEP maintains that for you. But whenever you pull your data out into ArcMap and you start editing data and adding records, you have to be conscious of that. And there were a couple of different solutions that we helped implement there. One was a little add-in to ArcMap that helps you generate those unique IDs on the fly and automatically. And then, of course, there was also some tricks you could do with uploading the data into VEP where it'll automatically generate that unique ID. And then as far as the unique IDs for the next-gen 911 data model is concerned, it was, gosh, I'm going to butcher this if I don't look, but it was the state URL plus the county plus a unique identifier on the end, a unique number on the end. And so that generated the URL for next-gen 911. Okay, so with the Gap 2 analysis document complete, we met with each one of the ECDs, reviewed that document in detail with them. There were some that simply did not have the bandwidth to do the remediation on their own. And so through the state board, we were able to step in and be their GIS arm, if you will, and actually remediate the data based on that Gap 2. And again, doing all that under a 18-month federal grant deadline. Okay, next let's talk about some of the additional tools that we added throughout the project. So again, we wanted to provide a solution to where the ECDs themselves could go in and make their own edits inside of VEP and do that in real time. So if the ECD chose to have their system of record live in VEP, they could do all of their addressing, they could create address points, they could range roads, they could remediate the data, change the data. There was even a little road range split tool, which seems like a very simple tool, but it was a huge time saver. So as you're adding roads into your road network and you have to split that geometry, if you simply go into ArcMap and split the geometry, now you've created a duplicate road range, and you have to go in and manually adjust that road range. Well, that split tool, you simply click on the intersection or the ESB boundary, and it'll split the road for you and adjust the address ranges along that road center line. For those who did not want to have their system of record living in VEP, we implemented some detached editing functionality and geofencing to where they could actually check out their data, take it into ArcMap, work on it, upload it back into VEP. And then there's also a method of simply just downloading your data out of VEP, pulling it back into ArcMap, and re-uploading it back into VEP whenever you're done. Observations were put in place to give the non-GIS folks the ability to have input. So think about observations as kind of your digital sticky note. And so, you see something wrong on the map, something that needs to be changed, you drop a point, give some information about the point, and that starts a whole email cycle chain, if you will, that notifies the data steward. The data steward makes comments about it, does whatever change is needed, and then the person that submitted the observation gets notification back, hey, I looked at this, yes, you're right, it's a duplicate address, we fixed it, so on and so forth. And then, well, we already touched on MSAG generator there, but MSAG generator allowed them to use their GIS data to not only generate a new MSAG, but compare that MSAG against their legacy MSAG to report changes up to the carrier. Okay, I mentioned this earlier on with, I'm doing on time, okay. The aggregator portion of the solution was an important part as well. So you've got each one of the ECDs has its own instance of VEP, and that's sort of the portal into the state aggregated data set, if you will. That's where each one of the ECDs does their validation work and submits data and so on. But then you have to bring all that together. You have to build the quilt, if you will, and sew everything together and stitch everything together. And so there's another instance of VEP, the aggregator VEP, that kind of sits above all 85 of those individual instances of VEP. And whenever the individual ECD has their data ready for aggregation, they simply mark it off as ready to aggregate. And that triggers a workflow process at the state level that goes in and grabs that data and starts combining that data into a seamless statewide data set for NextGen 9-1-1. And so you can imagine bringing all of those different localities together. Inherently, you're going to have questions along the border. I mean, not everybody's going to match up. We talked about the PSAP boundary earlier. The same's true for the provisioning boundary. The same's true for even your road center lines. You may have two road center lines that do this at the border. Well, you need them to actually join together. And so the aggregator solution, in combination with each individual VEP instance, goes 1/4 of a mile on each side of the border, and it starts looking for gaps and overlaps and things that don't match. Now, County A can't change County B's data, and County B can't change County A's data, but County A can run validations against County B's data to look at what needs to be changed. And then that strikes up a conversation between those two of, hey, I've got a gap here. I need to fix this gap with you. I need to figure out which, do I need to move my border? Do you need to move your border? Where does the center line actually go? Does this does the ESB boundary follow the river channel, or is it on the bank? Those types of questions. And so that brings all of the data together and allows you to start looking at any problems that you have along the borders there. And it does it not only for the boundaries, but all the other layers that are involved as well. Okay, so last slide here, and we'll leave some time for some additional questions. So we've got about another 15 minutes, but we're really proud of this project. We've been able to complete this within 18 months. We have all 85 ECDs online now, submitting data. Everything's been onboarded. And some of those ECDs are on different stages of data remediation and data readiness, but they have a solution in place now to where they can continually monitor that data, continually bring that data together into a statewide repository. We were able to do this during COVID lockdown. So VEP is a cloud native solution, and that was really played to our advantage with this project, because the ECDs, even though they were in lockdown as well, they could still participate in the project, and they could still bring data into VEP, and we could still work on the project. So it was just business as usual for us during COVID lockdown, as much as possible anyway. We were able to get it done ahead of time and under budget. And I think the things that really contributed to that, we've got some of the most advanced tools in the industry, the largest staff that I know in the industry. And then, we had a huge participation with the local ECDs and localities. I mean, there's no way that we could have done it without 100% participation from the localities. So that was a huge factor. And then the state leadership really, that's probably the main driving factor there, was the state board has excellent leadership in being able to pull this off. And they were able to help us navigate the project and, all the different channels that were involved, and the steps that needed to be taken and everything. So that's Alabama's journey towards next generation 911. There's still GIS data work to be done. but we now have a solution in place to where that's being accomplished, and we have a full working GIS solution there in the state of Alabama. All right, I will leave it open for some additional questions here.
All right, so there are a couple of questions that came up as you were speaking. So the first one, did the state require any consolidations of the ECDs? Oh, I think we asked that one already. Sorry, you guys, I'm trying to scroll and that's should queue these up ahead of time. There was one about, oh, is there any effort to edge match GIS data with neighboring states?
There actually is. So if you look at this section of Florida, I know it's grayed out, but and you start, let's see, there's Panama City, Port St. Joe. I'm guessing, but from about right here over, that's region 1. So it's 11 counties. And actually it's probably from right here over. So that's 11 counties in the state of Florida. And we were privileged to be working on that project at the same time that we were working on the state of Alabama. And we went through what we call boundary facilitation. That's something I didn't talk about during the presentation, but that's where you schedule we facilitate a meeting between the different localities, and we bring each other's data up side by side, and we start, hey, is this your area? We have an overlap here. Which one of you guys should move the border? And we do that to not only correct that, but to document that we met on this day. This was a decision that was made. We get sign off from everybody, and then we can actually go in and make those adjustments if they want us to. But we did that for all of the bordering counties along this area. I've not been involved in any discussions here along the state of Tennessee, but I know with Tennessee's state 911 project or Next Gen 911 project, unless I'm mistaken, I know that the state board's been talking with their counterparts there in Tennessee to edge match some of that data as well. But then when you get on the other sides of the state of Alabama, I mean, Georgia hasn't really moved forward with Next Gen 911. Neither has Louisiana, Mississippi. So there's not really the need to edge match just yet. But whenever those states start coming online, there'll definitely be some edge matching that takes place.
All right, awesome. It looks like we got a lot of questions coming up. So if there's anything we can't get to, just want to let everybody know that we will reach out to you after the fact. We have everyone's contact information it's all collected when you register. So all good there. What was the federal grant you used to help pay for this?
Oh gosh, that's something I should know and I don't. Let me get back to you on that, because I can get you the specific federal grant name.
All right. Is VEP a software that Datamark runs or that is operated by state now post-project completion?
It's operated by the state and the local ECDs. And that varies by project. We've got certain projects where there's another one spinning up in Florida where Datamark is serving as the aggregator, and it's something that we would run. But in this case with Alabama, the state 911 board is the aggregator for the entire state.
All right. And how do you handle complicated intersections?
So without a good example, that's kind of hard to answer, but complicated intersections on the road center line, I assume. I can think of several different things that may cause an intersection to be complicated, especially if it's if it represents a border. That would definitely throw something into the mix there, because you have to look at the right of ways and see, okay, does the main intersection point, does that fall within which jurisdiction does that fall into? And, you know, if you were to zoom into, let's see. Can't get to my stuff here. There we go. As you zoom into Jefferson County, you can imagine any of the intersections that fall along this little puzzle piece could definitely pose a problem. So you'd have to really go in and look at, you know, where does that intersection fall? Which jurisdiction should respond to it? You know, which PSAP does it go to? If a call comes from within that intersection, do I have the borders right to make that intersection happen? I'm hoping that's what you're referring to there.
All right. And our original person who asked the question confirms that yes, and yes, road center line. Okay, good. All right. And then how are PSAPs maintaining their data going forward? Are they using VEP or using ArcPro or other?
A variety of ways. So the state didn't want to force a single methodology towards everyone. So it really depends on the ECD's choice. So we have some ECDs that once they load their data into VEP, that's where their data lives, and they maintain everything through VEP. We actually have a really large customer there in Manatee County, Florida, and that's all they use is VEP. We have other folks that you know, maintain it in ArcPro. It's agnostic. VEP is agnostic. It doesn't require any specific version of ArcGIS. It doesn't care if you're using geodatabase or shapefiles. It does require ESRI data, so there's some translation that has to go into it. But there's a host of different ways that the ECDs are maintaining their data.
All right. Looks like we got keep popping up. Okay, so did all of the counties have data in the same projection system?
For the most part, yes. There were several variations. For the most part, it was you know, state plane coordinate systems, and part of that extract, transform, and load process takes it over to you know, next gen standard coordinate system (GTM). But there were some folks that already had their data in you know, UTM, but for the most part, yeah, state plane coordinates, and you know, it's reprojected as it's loaded into VEP.
Are fire, ambulance, law using the same data from the aggregated data?
So they can. It depends on you know, local ECD policy, but ultimately that's where we get those layers. You know, there's certainly variations to this, but for the most part, if they didn't already have a fire layer and it was a municipality, we followed the municipal lines. If they didn't have any of those layers, we would go back to the ESN layer and help generate those different ESB boundaries. But yeah, for the most part, they're using the same data.
All right, awesome. Does Alabama have a single EGDMS for its NG9-1-1 system, or does each ECD maintain their own with their EZNet providers?
So Alabama will have a single enterprise geodatabase management system through InDigital. So InDigital will be setting up the SI, and the VEP solution, the aggregator solution, will be feeding that SI.
Have you had any issues with certain counties not maintaining their data after they submitted initially?
I wouldn't call them issues. I mean, there's always bandwidth issues. You know, there's folks that are, I mean, they're just busy. These folks inside, they're tasked with making sure that you know, 911 calls get answered, and then, you know, especially a lot of the more rural and you know, lesser populated areas. I wouldn't say it's issues with maintaining their data or uploading. It's simply more of a time issue, And, in those cases, we've even stepped in and provided some managed services to help them with that.
All right. And then someone writes, what is the error budget for the GIS data being captured?
Oh, the error budget. So as far as fixing the errors, is that what you're talking about?
I'm assuming so, yes.
It varies. It depends on, a lot of times it depends on the local ECD budget. There was some of that federal money that was used to clean up the errors. We were able to do 46 ECDs, their data remediation and cleanup, using those federal dollars and using some state dollars. As far as the budget moving forward, I'm not privy to that with what the state has.
All right. And then we do have a couple of questions just asking us to clarify what VEP is. So could you kind of go into that a little bit, John?
Sure. So VEP is a cloud native solution. It's an enterprise GIS system that we've placed out on AWS cloud, and it gives you the ability to validate and edit and provision data for next generation 911. And this is, I'm stepping out on a limb here with a live version of VEP that I don't normally run. So, but this kind of gives you an example of VEP. And so you would upload your data into VEP, and in that upload process, you're able to run validations on your data. And see, I'll create a new validation here just to see. So you're able to run all validations, address point validations, so on and so forth. That generates the fallout list that you saw in Arc Pro. That generates these layers. It also puts those layers straight in the map in VEP. And so you're able to go through those layers and actually clean the data up here inside of VEP. And so it is a full enterprise system. There's edit sessions that are involved. Each time you go in and edit data, it's role based. And so you're able to check out a version, make all of your edits. When you check that version back in, the administrator has to approve all of your changes. And so in doing so, you're able to have multiple people working on cleaning up the data. And then once that data is clean, you're able to mark that data ready for aggregation. And then the aggregator product picks it up and aggregates it into a seamless data set.
Awesome. And then I think, just to clarify, because some people were asking, because we were saying VEP, validate, edit, provision. VEP is also the name of the product. So I know that can be a little bit confusing. We created it kind of for the public safety community. So we created the acronym and then just started calling it VEP, and then the name stuck. So that's where we're at with that. And then just a couple more questions. So someone off that VEP question asked, how accurate is the data?
It depends on how much effort you put into it. So once you run all the validations and you remediate all the validations, then you are what we call next gen 911 ready, or next gen 911 compliant. You also have to take into consideration exceptions. I mean, there's certain anomalies that we look at that's just simply the way it is out there in the real world. And I use the example of my courthouse in my hometown here is all the time. So if you drive down Main Street, you'll notice that the courthouse is on the wrong side of the street and it's out of order. That courthouse was built in the mid 1800s, and it didn't have an address back then, but I promise you, you're not going to change the address of that courthouse. And so you have to mark that off as an exception. So those exceptions play a role in accuracy as well. So, the main thing of accuracy is to get the data ready to route 911 calls with. You have to be able to use your GIS data to tell the same story, at least tell the same story as your telephony data does today, and even be more accurate, if you will. So it's all about how much work you put into it.
All right, and it looks like we are at the top of the hour. So for anybody, I know we have a couple of additional questions specifically around our product. So we will go ahead and email each one of you individually with answers to your questions. I am excited to announce we also have a brand new website. So if you are interested in learning more about any of our solutions, please feel free to visit datamarkgis.com. I will add it into the chat. Like I said, this is the first webinar of the year, and we have a bunch of exciting content that we're getting ready for you for the rest of the year. So if you guys are interested in visiting any additional webinars, please also visit our website at datamarkgis.com/events. You can find everything there. This webinar was recorded. We will put it up on our YouTube channel. If you guys have any questions, please feel free to reach out to me or John directly. I will make sure to leave our emails in the chat and then also in the follow-up email that we will send out early next week. So thanks, everyone. John, did you have anything else you wanted to say?
I just want to thank everyone for, man, we had a huge attendance today, and I really appreciate the attendance and the questions. I almost forgot to drop the story map here. So let me drop that in the chat and you'll be able to access that. Feel free to take a look at that. And as Stephanie said, if you have any questions, man, please feel free to reach out. I'd love to talk to you.
All right, thanks everyone. And I'll be leaving our emails in the chat if you're interested. Have a good one. Bye.
Thank you all. Bye-bye.